Cement, the foundation of modern civilization. This seemingly simple powder is the key ingredient in concrete, the second most consumed substance on Earth after water. From the skyscrapers that define our cityscapes to the bridges that connect our communities, cement plays a crucial role in shaping the world around us. But how is cement made in factory? Raw materials and quarrying and extraction. The two primary ingredients in cement are limestone and clay. Limestone, rich in calcium carbonate, provides the essential calcium, while clay contributes silica, alumina, and iron oxide. These natural materials have been nature's building blocks for millions of years, long before humans decided to get in on the construction game. In addition to limestone and clay, cement manufacturers incorporate other additives to enhance the final product's properties. Gypsum plays a crucial role in controlling the setting time of cement, ensuring it doesn't harden too quickly during use. Another common additive is fly ash, a byproduct of coal-fired power plants. The journey from earth to cement begins in vast quarries, where limestone and clay are extracted through carefully planned and executed operations. Modern quarrying employs sophisticated techniques to efficiently remove these materials from the earth. Powerful drills create holes for explosives, which are then detonated in controlled blasts to break up the rock face. Enormous excavators and front-end loaders then scoop up the fractured stone, loading it onto equally impressive haul trucks. These trucks, often large enough to make your average car feel like a toy in comparison, transport the raw materials to the primary crusher. Here, the rocks begin their transformation from imposing boulders to more manageable pieces. In some cases, particularly for quarries located far from the cement plant, the crushed materials might be transported via long conveyor belts or even dedicated railway lines. Raw material preparation and preheating. The true metamorphosis, however, occurs when the raw materials reach the factory.
What's next?
First, these chunky rocks must be reduced to a very fine, uniform powder. This is done by the series of crushers and grinders, each one more formidable than the last. The biggest chunks get crushed by the primary crusher, while the material gets turned into a fine powder by the secondary crushers and ball mills. It's like the most extreme version of rock, paper, scissors ever played, except here, rock always loses. With the material sufficiently crushed, some precision mixing is in order. Cement is a very critical composition, so the engineers take care in mixing the limestone, clay, and additives in a very specific formula. The mixture, now called the raw meal, is next homogenized to create uniformity. Here, the raw meal is fed into the preheater tower, the towering structure of modern engineering that may reach as high as 120 meters. While the raw meal is moving down the tower, it encounters an upward current of extremely hot gases from the kiln beneath. This creates a countercurrent heat exchange in which the raw meal is constantly heating up and readying for the extreme temperatures inside the kiln. Preheating performs a few very key functions. It initiates chemical reactions that will be completed within the kiln, thus giving them a head start. The precalcination can be as high as 40% of the transformation of the material. This process of preheating increases the energy efficiency of the whole cement-making process quite substantially. The preheater, by tapping into the hot exhaust gases emanating from the kiln, reduces the total energy consumption and, in so doing, helps lower the carbon footprint of cement production. When our raw meal leaves the preheater tower, it is not just warm. It's hot as can be, 900 degrees Celsius or so. But this is just the appetizer for what is about to follow, for things are going to get really hot once we reach the heart of the whole cement manufacturing process, the rotary kiln. Kiln processing and clinker formation, the heart of the cement factory, the rotary kiln. This massive cylindrical furnace is the centerpiece of cement production, where the magic, or should we say the chemistry, happens. Imagine a giant tube, up to 200 meters long and 6 meters in diameter, slowly rotating and tilted at a slight angle. This behemoth is where our preheated raw meal undergoes its most dramatic transformation. As the kiln rotates, the material inside slowly moves from the upper end to the lower end, encountering increasingly higher temperatures. At the lower end, fuel is burned, creating a fiery inferno that reaches an astounding 1,450 degrees Celsius. To put that in perspective, that's about a quarter of the temperature of the sun's surface. It's safe to say that if you're looking for a place to roast marshmallows, this isn't it. Inside this inferno, a series of complex chemical reactions occur. The extreme heat causes the calcium carbonate in limestone to break down into calcium oxide and carbon dioxide. This calcium oxide then reacts with the other components, silica, alumina, and iron oxide, forming new compounds. It's like a molecular dance party, with atoms swapping partners at an atomic rave. The result of this high-temperature tango is clinker, small, dark gray nodules that are the essential ingredient of cement. Clinker formation is a crucial stage in cement production, as these nodules contain all the components necessary for creating the final cement product. As the newly formed clinker exits the kiln, it needs to cool down, and fast. The cooling process is critical, as it affects the final properties of the cement. Clinker is rapidly cooled from about 1,000 degrees Celsius to 100 degrees Celsius using large volumes of air. This rapid cooling not only makes the clinker easier to handle, but also freezes the mineral composition, ensuring the desired reactive properties are maintained. Final grinding and storage and packaging. As our clinker cools down, it's ready for the final transformation into cement. This stage begins with the addition of gypsum and other supplementary materials. Gypsum plays a crucial role in controlling the setting time of cement, ensuring it doesn't harden too quickly when mixed with water. Other additives might include fly ash, slag, or limestone, each contributing specific properties to the final product. The clinker and additives are then fed into giant grinding mills. These mills are like industrial-strength coffee grinders, pulverizing the materials into an incredibly fine powder. The grinding process is so intense that a single particle of cement can have a surface area of 300 to 500 square meters per kilogram. That's about the size of a basketball court packed into a particle smaller than a grain of sand. Once ground to perfection, our cement is ready for storage. It's pneumatically conveyed to massive silos that can hold tens of thousands of tons. These towering structures keep the cement dry and ready for distribution. It's like a five-star hotel for cement, minus the room service and minibar. When it's time to leave the silo, cement can take one of two paths. For bulk orders, it's loaded directly into specialized tanker trucks or rail cars. For smaller quantities, it's time for the bagging process. High-speed machines fill and seal bags with precision, typically in 25 kilograms or 50 kilogram sizes. These bags are then stacked on pallets, ready for their journey to construction sites, hardware stores, and anywhere else cement is needed.